Our next person is Trevor Cotter. He is presenting on using injectable liquids to prevent stroke, Master of Science in Applied Physics, and his advisors are Christopher Mann and Timothy Becker.
When you hear the word physics, what's the first thing that pops into your head? Many of you will think of complicated equations, geniuses like Einstein and Hawking, and if your first physics experience was anything like mine, many frustrating evenings considering other careers. Despite all this, after looking back on my first year of physics, I realized that while everything seemed very complicated at the time, it was very much simplified. Take a baseball flying through the air. We pay attention to certain variables, such as mass and velocity, but we completely ignore many others: wind, air resistance, shape of the ball. We do this because although it's not perfectly representative of what's going on in real life, it's still representative enough to give actual reasonable results. This is exactly what we do in my research. We study brain aneurysms, which occur when small areas of blood vessels of the brain swell up into a balloon-like structure, like you can see there. Eventually, these will burst and cause a stroke, which is fatal 40% of the time. Similar to the baseball flying through the air, we can reduce aneurysms into a few key variables. We have the force, F, which basically is how hard the aneurysm wall is working to hold itself together under your internal blood pressure, P, just from the beating of your heart. And then finally, we have the radius, R, which is just the size of the vessel. As P and R change, the force in the wall must also change according to the equation in the middle. If P goes up, the force must go up. If R goes down, the force goes down. Physicians can use drugs to lower the internal blood pressure, and you can stop exercising to lower that as well, but eventually these will continue to grow and eventually burst. When the max force, the max amount that the wall can hold, is overcome, it will burst and cause your stroke. We treat this by filling the aneurysm with a gel. We make a small incision near the groin, snake a tiny tube up all the way into the brain, into the aneurysm, and inject our gel through there. It cures in place and seals the aneurysm off. It can heal itself and seal itself off from the internal blood pressure, eliminating P and also the force from the equation there. On the right, we can see two different X-ray images where blood vessels are shown in white and black. In the top, we have an aneurysm that's circled, and in the bottom, we've injected it with our gel, and it's no longer visible, meaning that it's completely cut off from the internal circulation. There's no P and no risk for rupture. This is a game changer for the medical field. By taking this complicated system with changing blood pressures, different tissues, reducing it to a few key components, and eliminating one of them, we now have the potential to save over 2% of the US population, 6 million people here, and millions more around the world. Thank you.